Okay, question 21. We've got a function here and someone's been kind enough to complete the square on that function. Point A is the maximum point on the curve and write down the coordinates of A. Okay, so it's fairly obvious that the curve is some kind of N-shaped quadratic. And the routine to work out the coordinates of the maximum point is to say that this term itself, ignoring the minus for the moment, is determined to be positive. Doesn't matter what value of x you choose, this guy is going to be positive. The only time it's not positive is when the bracket is 0, and that happens when x is equal to -2. When x is -2, this guy goes to 0, which means the 9 remains unchallenged as a maximum value. You see, at any other point, the 9 is pulled down in value. So this must be 9. And the point at which 9 is left alone unmolested is when x is -2. Otherwise, the curve is pulled down by the increasingly negative value of our second term. Okay, so the coordinates of A are equal to -2, 9. The numbers really are staring you in the face here. Okay, let's have a look at part B. The curve is transformed to a new curve by a translation of an x shift of 4 and a y shift of 0. Find an equation for the new curve. And I've popped that onto our axis. As you can see, the curve has moved by 4 units to the right. How do we express that in our function? Well, you've got to remember that when you move a curve to the right, you take 4 away from the x value. It's the big elephant trap. Fx of s is equal to 9 minus 3, and this will be x minus 4 plus 2 squared. So tidying that up, we get 9 minus 3x minus 2 squared. And that is your answer. So let's have a look at part C. What they're now saying is our original curve, which is fx, is transformed to the curve t, where t has the equation of this. Well, what's happened? Well, what's happened is that the 9 has become negative, and the negative term, the x squared negative term, has become positive. So the whole lot has been multiplied by -1. So I can say that t is equal to fx multiplied by -1. What does that do? Well, it reflects the curve in the x-axis. So at the risk of crowding this diagram with loads of red lines, this is the curve t. The 0 points don't move, but this maximum at +9 has gone down to -9. How do we express that? Well, it's a reflection in the x-axis. And that is your answer. This is the question that never ends. We've been given a graph that was a cosine graph, but it's been transformed. So we need to work out what's happened to it. Okay, to help us, I've put on an unchanged cosine graph existing between 1 and -1. Peak at 1, goes down to 0 at 90, climbs back up to 1 at 360 degrees. So let me write down what our equation is. Y is equal to A cos x minus b plus c. And because our peak-to-peak value of the red curve, which is 2, has gone up to 6 for the white curve, A must equal 3. So I filled in one of the blanks in our new equation of the white line. So let's continue on with vertical transformations. Okay, so with an amplitude of 3, I'd expect the white line's peak to be at 3. But it's not, it's at 5. So the whole graph has been shifted vertically upwards by 2. So I can add a new value to our transformed curve in that C is equal to 2. Now just looking at the horizontals, the peak that was at 0 degrees is now, the white line, at 90 degrees. And it's been shifted backwards. That means we've added effectively 90 degrees to this. So B must be equal to negative 90. So this turns out to be positive 90. So those two results are your answers.